7, the place where we learn ethical hacking and cybersecurity the right way. Today, I've got something super practical for you. We're talking about a training that teaches you how to hack websites like a real attacker, and more importantly, how to secure them like a pro. So, if you've ever wondered what web hackers really do behind the scenes, stick around. All right, so here's the deal. This course is all about understanding how websites and web apps get hacked and how to stop those hacks. Now, before you panics, yes, this is 100% legal. It's ethical hacking. You'll be practicing in safe environments using real vulnerabilities in test labs. So it's not just some theory from a textbook, it's real-world stuff. Let me break it down. Here's what you'll actually learn in this training. First, how the web works, like HTTP, cookies, sessions, basic stuff, but super important. Then you get into recon, finding targets using tools like Google dorking, subdomain tools, and scanning ports. After that, you dive deep into vulnerabilities, the juicy stuff. We're talking SQL injection, cross-site scripting, XSS, file upload bypass, command injection, login bypasses, and access control flaws. You'll not only exploit them, but also learn how to fix them. Now, this is the best part. You're not just watching videos. You'll actually do the hacking yourself. With real working labs, you'll try these attacks on purpose-built vulnerable websites. And once you break in, you'll learn how to patch the issues, secure the code, and defend against future attacks. So you'll see both sides, the attack and the defense, which is exactly how a real ethical hacker thinks. And don't worry, you won't be left in the dark with tools. You'll get comfortable using tools like Burp Suite, OWASP Zap, sqlmap, Nikto, Hydra, Derb, Postman. Yep, even that. Even if you've never used these before, the training walks you through step by step. Now, you might be wondering, is this course for me? If you're just starting in ethical hacking, a student prepping for CEH or OSCP, a developer wanting to secure your code, or even someone just curious about cybersecurity, then yeah, this is for you. You don't need to be a pro. You just need to be curious. Let's be real, cybersecurity is hot right now. Knowing how to hack and defend web apps is one of the most in-demand skills today. This training is a great foundation if you want to go into bug bounty hunting, web app pen testing, security engineering, even freelance consulting. And guess what? It even helps you prep for certs like OSWHOIS, CEH, and EWPT. Here's what's included in the training package: lifetime access to lessons, step-by-step labs, downloadable resources, and a certificate at the end. It's like a full boot camp, but focused just on web hacking. All right, if you're serious about learning how real hacking works and you want to level up your skills, check the link in the description. That's where you can get access to this course. And of course, if you found this video helpful, hit that like button, subscribe to Secure 7, and leave a comment if you have any questions. Thanks for watching. Stay ethical, stay curious. I'll see you in the next one. Back to 7, the place where we learn. Hey everyone, welcome back to Secure 7, your go-to channel for learning ethical hacking from scratch. Today, we're kicking off Module 1 of our course, and we're starting with something every hacker needs to master: a basic overview of Kali Linux. If you've ever wondered, what is Kali Linux? Why do hackers use it? You're in the right place. Part 1. What is Kali Linux? So let's start with the basics. Kali Linux is a specialized Linux distribution created specifically for penetration testing and ethical hacking. It's built and maintained by Offensive Security, and it comes preloaded with hundreds of tools used by hackers, security professionals, and forensic analysts. Think of it like a hacker's Swiss Army knife. It's got everything from network scanners to password crackers. And the best part? It's free, open source, and based on Debian. Why use Kali Linux? Now you might ask, why Kali? Why not Ubuntu or Windows? Well, here's the thing. With Kali, you don't have to install tools one by one. Everything is optimized for hacking and security. It runs on low-spec machines. It's constantly updated for security pros. So instead of building your own hacking machine from scratch, Kali gives you a fully loaded lab ready to go. All right, let's take a quick tour of the Kali desktop. So when you first boot Kali, you'll see a clean interface, usually running XFCE or GNOME, depending on what you chose during install. Let's look at what's on the left. You've got shortcuts for Terminal, File Manager, and Browser. On the top bar, you'll find Settings, Power, Wi-Fi, and more. And of course, your Applications menu is where the magic happens. Open it up and you'll see categories like Information Gathering, Vulnerability Analysis, Web Application Attacks, Password Attacks, Wireless Attacks. Each of these folders contains powerful tools you'll learn to use throughout this course. Let me show you some of the tools that come pre-installed. Nmap for scanning networks, Burp Suite for testing web apps, Wireshark for capturing packets, Metasploit for launching exploits, John the Ripper for cracking passwords, Hydra for brute force attacks. And that's just scratching the surface. Everything is organized by purpose. So even if you're a beginner, it's easy to find what you need. Now, Kali is still Linux under the hood, so you'll be working a lot in the terminal. You'll see a home folder, root access, and a very typical Linux-style file system. We'll go deeper into terminal commands in the next module, but just know, if you want to unlock Kali's full power, you need to get comfy with the command line. Don't worry. It's easier than it looks, and I'll walk you through it step by step. Kali isn't something you use as your daily OS like Windows or Mac OS. Instead, use Kali when you're testing networks or websites, practicing CTFs or challenges, doing lab work for your certifications, or working in a controlled, ethical hacking environment. Pro tip, always use Kali in a virtual machine or a separate setup, never for everyday browsing or personal work. So there you have it. Your basic overview of Kali Linux. It's the platform you'll be using throughout this course to scan, test, hack, and secure. In the next module, we'll jump into the Linux terminal and start writing our first commands. If you found this helpful, give the video a thumbs up, subscribe to Secure 7, and turn on the bell so you don't miss the net. Let me know in the comments. Are you using Kali for the first time, or have you tried it before? This is Parth from Secure 7, signing off. Stay ethical, stay curious. I'll see you in Module 2. Hey, what's up everyone? Welcome back to Secure 7. This is part 2 of Module 1 in our ethical hacking series. In part 1, we talked about Kali Linux and why it's the go-to OS for hackers. But now, it's time to dive into one of the most important skills you'll need as a hacker, using the Linux terminal. Yeah, that black screen with blinking text, we're about to make it your best friend. So let's start from the top. The Linux terminal is just a command line interface. Basically, it lets you type instructions directly to your operating system. No clicking, no dragging, just raw power. Think of it like this. When you use the terminal, you're skipping the fancy visuals and going straight to the brain of the computer. When you open the terminal, you'll see something like this. Bash Kali, charge down. Let me break it name. Kali, your machine's host name. Means you're in your home directory, means you're a normal user. If it's hash, your root. If it's hatter, your root. This is where all the magic begins. Let's learn to move around in the terminal. Where am I? Bash pwd. This tells you the current directory, your location in the system. What's in here? Bash ls shows all the files and folders in your current location. Let's go into a folder. Bash cd desktop. Now we're inside the desktop directory. Go back one step. Bash cd, go home anytime. Bash cd ch. It's just like browsing folders on Windows, but way faster once you get used to it. Now, let's create and manage some files. This is where you start to feel powerful. Create a folder. Bash mkdir test folder. Move into it. bash cd test folder. Create a new file, bash touchfile1.txt. Check the contents of a file, bash catfile1.txt. It'll be blank for now, but we'll learn to edit it later. Remove a file, bash rm file1 text. Delete a folder, bash cd rm-r test folder. Clear the screen, bash clear. Boom, clean slate. Now, if you ever forget what a command does, no worries. Use man, short for manual. For example, bash man ls. It opens the help page for the ls command. Use the arrow keys to scroll and press Q to quit. Every command has a manual. It's like having Linux's built-in guidebook right in front of you. Sometimes you'll need admin privileges for installing tools or editing system files. That's where sudo comes in. Example, bash sudo apt-update. The system may ask for your password. Just type it and you're good. But be careful, sudo gives you full control, so don't go deleting system files by accident. Let's quickly recap what we learned. Navigating the file system, creating and deleting files, using the manual man, running admin commands with sudo. And this is just the start. The more you use the terminal, the faster and smarter you'll become. Soon, typing commands will feel just as natural as opening apps. All right, that's it for part 2 of Module 1. In the next module, we're going to set up our hacking lab using Metasploitable so we can practice everything in a safe environment. If you found this helpful, smash that like button, subscribe to Secure 7, and drop a comment below if you're new to Linux. This is Parth from Secure 7, and I'll catch you in Module 2. Stay ethical. Stay curious. Peace. Hey everyone, welcome to Module 2 of our course, Learn Website Hacking and Penetration Testing from Scratch. In this module, we're talking about something really fundamental. What is a website? How does it work? And why does understanding this matter so much in ethical hacking? Trust me, once you really understand how websites function, breaking them ethically becomes a lot easier. All right, let's keep this simple. A website is just a collection of web pages hosted on a web server and accessed by a browser. So when you type in www.google.com, what's actually happening? Your browser sends a request to a server, and that server responds with a page, like a search box or a YouTube video, that gets displayed in your browser. That whole back and forth communication is what makes websites work. Think of it like ordering food in a restaurant. You, the browser, make a request, the kitchen server prepares it, and the waiter brings it back as a response. Now, every website has 2 major parts. The front end, that's the stuff you actually see. Text, buttons, forms, images, all built using HTML for structure, CSS for design, JavaScript for interactivity. The backend, that's where the logic lives. This is the server side, where data is processed, stored, and served back. Technologies like PHP, Python, Node.js, databases like MySQL or MongoDB, all of this is backend. And as an ethical hacker, you need to understand both sides because vulnerabilities can exist anywhere. Let's go one step deeper. Let's talk about how websites actually work behind the scenes. 1. You open your browser and type in a website address. 2. The browser sends an HTTP request to the server. 3. The server checks what you asked for, maybe a login page or some data for. It sends back an HTTP response, usually an HTML page 5. Your browser renders that and displays it on screen, sex. This whole cycle is part of what we call the client-server model. The browser is the client, the web app lives on the server, and every time you open a web page, you're creating that communication. Let's also understand the difference between 2 types of websites. Static websites. These are simple pages. What you see is exactly what's coded. Nothing changes unless the developer updates the file, like a basic portfolio site. Dynamic websites interact with users. They fetch data from a server, process it, and show different results, like your social media feed, shopping carts, or dashboards. And here's the key. Most hacks happen on dynamic websites, because that's where user input meets server logic. That's where things can go wrong. So why are we even learning this? Because ethical hacking, especially website hacking, starts with understanding how web apps actually work. If you don't understand where data is stored, how it travels, what the client can access, and how the backend processes input, then you won't know where to look for vulnerabilities. Knowing the basics of websites helps you think like both the developer and the hacker, and that's exactly the mindset you need. Let's quickly recap. A website is a collection of pages stored on a server. The front end is what users see. The back end is what runs behind the scenes. HTTP requests and responses make it all work. Static sites are simple. Dynamic sites are interactive and risky if built poorly. And understanding this is your first real step into web hacking. All right, that wraps up the website basics part of our journey. In the next part of Module 2, we'll start talking about how websites are actually hacked. Real techniques, real logic, and real tools. So make sure you hit that subscribe button if you haven't already, and let's keep going. This is Parth from Secure 7. Stay ethical, stay curious. I'll see you in the next lesson. Hey everyone, welcome back to Module 2, Part 2 of our course. Learn website hacking and penetration testing from scratch. In the previous lesson, we talked about how websites actually work, the front end, the back end, and how they communicate. Now, let's get into what you've probably been waiting for. How do hackers actually hack a website? Let's break it down step by step, the legal way, of course. Let me tell you something right away. Hacking isn't just running tools and hoping something works. It's a structured process. It's about understanding, observing, and then exploiting the weak points. So when hackers target a website, they usually follow a step-by-step methodology. Let's walk through those steps, and I'll explain each one like we're in a real-world scenario. Step 1 is recon, or information gathering. Here, we try to collect as much detail as possible about the website, what technologies it uses, what CMS it's running, like WordPress or Joomla, which ports are open, what subdomains exist, even email addresses or login portals. Tools you can use: WHOIS, NSLOOKUP, Google Dorking, the Harvester. The more you know, the more you can target. Once we gather intel, the next step is scanning to find entry points. We scan for open ports, running services, directories and hidden files, login panels, vulnerable software. Tools you'll use: Nmap to discover services and ports, Nicto to scan for vulnerabilities, Burp to brute force directories, Wapalizer or WhatWeb to detect CMS and technologies. This gives us a technical map of the target and possible places to poke. Next up, the real hacking begins. Now that we know what the site is running, we start testing for vulnerabilities like SQL injection to mess with the site's database, XSS, cross-site scripting to inject scripts, command injection to run system-level commands, file upload flaws to upload malicious files, auth bypass to skip login pages, broken access control to access restricted areas. You can use tools like Burp Suite, OWASP Zap, sqlmap, or test manually by tampering with URLs and forms. This is where creativity meets logic. You think like a developer and attack like a hacker. If you find a real weakness, now you move to exploitation. This means using the vulnerability to gain access or extract data. For example, use SQLe to dump usernames and passwords, use a file upload bypass to plant a shell, use XSS to steal session cookies. But here's the ethical rule: never exploit without permission. In real-life jobs or bug bounty programs, your goal is to prove the vulnerability exists, not destroy or steal. Now, ethical hacking ends with one final but super important step: reporting. You write a clean, professional report explaining what the vulnerability is, how you found it, proof of concept, how to fix it. In bug bounties, this is how you get paid. In corporate jobs, this is what gets you promoted. Let me say this clearly: never hack any website without permission. Use practice labs, CTF platforms, or vulnerable machines like DVWA, Metasploitable, or WebGoat. Hacking is powerful, and with power comes responsibility. We're here to learn, practice, and protect, not to damage or steal. Let's recap the 5 stages of hacking a website. 1. Recon. Gather info. 2. Scanning. Find entry points. Finding vulnerabilities. Test the site. 4. Exploitation. Prove the weakness. 5. Reporting. Help fix the issue. This is the ethical hacker's path. And trust me, once you master it, you'll look at the internet completely differently. In the next lesson, we'll go hands-on with some of the tools I mentioned and start scanning real sites in a safe lab setup. If you learned something new today, drop a like, subscribe to Secure 7, and leave a comment if you're excited to start hacking. This is Parth, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in the next video. Hey everyone, welcome back to Secure 7, and this is Module 3, Part 1 of our course, Learn Website Hacking Penetration Testing from Scratch. We're now entering a very exciting phase: information gathering, also known as reconnaissance. In this video, we're starting with one of the most basic and important tools you'll ever use as an ethical hacker, WHOIS lookup. Before we attack any website, we need to know what we're dealing with. That's where information gathering comes in. We collect as much publicly available data about our target as we can. Things like who owns the domain, when was it registered, what IP address does it resolve to, where are the name servers located. This is all passive recon, meaning we don't touch the website or interact with the server directly. We're just looking at public records, and one of the best places to start is with a WHOIS lookup. Is basically a database of domain registration information. Every time someone buys a domain name like secure7.in or example.com, they have to register it with details like their name, email address, registrar name, date of registration, expiry date, DNS name servers. WHOIS lets you query that data and see who owns what. It's like doing a background check on a domain. All right, let me show you how to actually use WHOIS in real life. If you're using Kali Linux, just open your terminal and type bash whois example.com. You'll get a whole bunch of information like domain name, registrar info, registration and expiration dates, contact emails sometimes, name servers, IP address if DNS is exposed. This tells you who registered the site and maybe even when they last updated it. And sometimes you'll even find email addresses or technical contacts, which can help you with social engineering in legal bug bounties, of course. Now you might be asking, okay, cool, but how does this help in hacking? Here's the deal. Knowing the domain registrar can help you understand how secure their backend might be. If the domain is linked to other sites, you can discover related targets. If the WHOIS data is public, you might find email addresses or organization names. If the domain just recently changed hands, it could mean a new system or a vulnerable transfer. Think of WHOIS as your digital footprint tracker. You start seeing patterns, and patterns lead to targets. Now, keep in mind, WHOIS isn't always perfect. A lot of domains now use privacy protection services. So instead of showing personal info, they show a generic registrar like WHOIS Guard Protected or Private by Namecheap. Also, the GDPR privacy laws in the EU hide personal info in many cases. But still, even partial WHOIS data is valuable in the recon phase. Screen recording showing real domain lookup. Let me give you a real-world example. Let's look up the domain bash.whoistesla.com. Pause for live output. As you can see, it gives us the registrar, Mark Monitor Inc., domain status, dates of creation and expiration, the name servers being used. We didn't even touch the website, and we already have good intel. Let's recap. WHOIS is a great starting point for gathering domain-related info. It shows us who owns a domain, when it was registered, and what servers it uses. It helps us map targets and plan our next recon steps. This is passive, legal, and super useful. That's it for part 1 of information gathering. In the next video, we'll explore more recon tools like nslookup, the harvester, and how to find subdomains, all without ever touching the target directly. So hit that like button, subscribe to Secure 7, and leave a comment if you're enjoying this course. This is Parth, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in the next lesson. Hey everyone, welcome back to Secure 7, and this is Module 2, Part 2 of our course, Learn Website Hacking Penetration Testing from Scratch. In the last lesson, we learned how websites work. Front-end, back-end, static, dynamic, the basics. Now we're going a bit deeper. Today we'll learn how to discover the technologies a website is built with. And trust me, this is one of the most important steps before you start hacking. Before we attack or test anything, we need to know what tech stack the website is using. Here's why it matters. If it's built on WordPress, you might check for outdated plugins. If it's using Apache, you may look for misconfigurations. If the backend is in PHP, Node.js, or Python, your testing methods will change. Even the JavaScript frameworks used, like React or Angular, can give you clues on how client-side validation works. Knowing the technologies helps us choose the right tools, techniques, and payloads. And the best part? You can find out a lot without touching the server, just by analyzing the site. Let's start with some easy online tools that anyone can use. 1. Wapalizer. Go to wapalizer.com, tenant/flu.wapalizer.com, and enter any website, like example.com. It'll show you web server type, Apache, Nginx, CMS used, WordPress, Joomla, Shopify, JS libraries, jQuery, React, programming languages, PHP, Python, analytics tools, Google Analytics. You can also install the Wapalizer browser extension, and it shows you this data in real time while browsing. Another great tool is builtwith.com, dps/built.com. It's similar to Wapalizer, but sometimes gives even more detailed info, like email service providers, SSL certificates, CDN content delivery networks, hosting providers. Both tools are passive. You're just analyzing what's publicly visible. If you prefer using terminal tools like a true hacker, here are some CLI options. WhatWeb pre-installed on Kali Linux. Run it like this: bash whatwebexample.com. It will try to fingerprint web server, CMS, frameworks, scripts. Sometimes it's faster than Wapalizer, and it works right from your terminal. Netcraft. Netcraft also has a website profiler, tate/sitereport.netcraft.com. Just enter the domain and you'll see hosting provider, country of origin, technologies in use, site history. These tools help you fingerprint the target without raising alarms. That's smart recon. So now that you've found out what tech the website uses, what next? Here's how you use that info. If it's WordPress, search for vulnerable plugins. If it's running PHP 5.x, check for outdated components. If Apache is the server, look for directory listing or misconfigured.htaccess. If there's a login form, you might test for SQLA or brute force it using Hydra. This recon lets you plan smart, targeted attacks. Ethically, of course. A quick reminder: always do this kind of scanning and fingerprinting on your own lab environments or sites where you have explicit permission. Never run active scanning or probing on live targets that don't belong to you. That's illegal. But these passive tools like Wapalizer, Built With, and WhatWeb are usually safe for exploring public data. Let's wrap this up. Before testing any site type, discover the technologies it's using. Use tools like Wapalizer, Built With, and WhatWeb. The more you know about a site's backend, the smarter your testing will be. And remember, information is power, but only if used ethically. All right, that's it for part 2 of Module 2. In the next lesson, we'll use this information to begin mapping the website, finding subdomains, directories, and hidden pages. Make sure to like, subscribe, and drop a comment below if you're enjoying the course so far. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in the next module. Hey everyone, welcome back to Secure 7, and this is Module 3, Part 3 of our course, Learn Website Hacking Penetration Testing from Scratch. In the last few lessons, we looked at WHOIS, IP lookups, and discovering technologies on a website. Now, we're moving into something even more powerful, gathering DNS information about our target. So why is DNS important? DNS stands for Domain Name System, and it acts like the internet's phone book. It translates domain names like google.com into IP addresses. Now here's the thing, DNS records can tell us a lot about a target, like where it's hosted, which subdomains exist, if mail servers or test environments are exposed, what kind of infrastructure they're using. This information can lead to finding hidden systems, forgotten admin panels, or even internal development sites. As ethical hackers, we use it to map the target better. Let's quickly go over the main types of DNS records we care about. A record maps a domain to an IPv4 address. AAA record maps to an IPv6 address. CNAME, canonical name, alias for another domain. MX record, mail server info. NS record, name servers, who controls DNS. TXT record, text data, sometimes contains verification or SPF settings. SOA record, start of authority, gives basic DNS zone info. Every one of these can provide clues, especially subdomains and MX records, which are often overlooked in security setups. Let's do some practical work using a built-in tool. NSLookups. It's simple and powerful. Open your terminal and type bash nslookup example.com. This gives you the IP address of the domain. Want to find mail servers? Bash nslookup-type=mx example.com, looking for name servers. Bash nslookup type =ns-example.com. You can even use it interactively. Nslookup set type =any example.com. This is how you gather basic DNS records in seconds. Now, if you want more detailed DNS results, I highly recommend using dig. Just type bashdigexample.com. It gives you query time, DNS server used, TTL, time to live, all returned to records. Want to find everything in one shot? Bashdiganyexample.com. To check mail servers, bashdigmxexample.com, or for name servers, bashdignsexample.com. The best part about Dig is how clean and structured the output is. It's perfect for scripting or documentation. One cool trick is to do a reverse DNS lookup. This means converting an IP address back into a domain name. You can try bash nslookup 93.184.216.34. This sometimes reveals test environments, hidden subdomains, or old systems still pointing to the server. So how does this help you as a hacker? You find admin panels running on subdomains like admin.target.com. You identify third-party email services which might be vulnerable. You learn how many servers or CDNs the target uses. You sometimes find forgotten dev environments, staging sites, or old DNS entries. The more you map up front, the easier it is to attack later. Clean, targeted, and efficient. Let's do a quick recap. DNS records reveal a lot of technical info about a target. Tools like nslookup and dig let you pull A, MX, TXT, and other records. This is all passive and legal as long as you're gathering public data. DNS Recon helps you build a smart attack plan without triggering alerts. That's it for this part of the information gathering module. In the next lesson, we'll move to subdomain enumeration, where we try to discover hidden parts of a website's infrastructure. Make sure to like, subscribe, and turn on notifications if you're learning something new. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in the next one. Welcome back to Secure 7, and you're watching Module 3, Part 4 of our course, Learn Website Hacking Penetration Testing from Scratch. In the last video, we explored DNS records and how to gather valuable domain-level data. Today, we're taking the next step in Recon, subdomain enumeration. A critical skill for any ethical hacker or bug bounty hunter. So what exactly is subdomain enumeration? Every website has its main domain, like example.com, but many websites also have subdomains, like admin.example.com, mail.example.com, dev.example.com, api.example.com. These are often used for internal tools, login panels, test environments, or APIs. If a subdomain is exposed and misconfigured, it could be an open door into the entire system. So as hackers, finding these hidden subdomains is a major part of our recon process. Think about it. Companies often forget to secure staging and dev subdomains. Login panels or admin portals are often hidden under subdomains. Older apps may still be live, but completely forgotten. Some subdomains even point to third-party platforms like GitHub pages, Heroku, or AWS, which might be vulnerable to subdomain takeover. So the more subdomains you find, the bigger your attack surface becomes. There are two main ways to find subdomains. Passive enumeration. You use public sources to gather subdomain info without interacting with the target server directly. Active enumeration. You brute force or scan DNS records to find subdomains which may generate traffic or logs. Both are useful, and we'll look at tools for each. Let's start with passive methods. These are safer and stealthier. got.sh//yushkin. It enter the domain like target.com. This shows SSL certificate logs and often reveals hidden subdomains. Visit virustotal.com, total.com, search the domain and go to the Relations tab. You'll see linked subdomains. Sublist3r, tool in Kali Linux. Run this command, bash sublist3r-d example.com. It gathers subdomains from multiple sources like Google, Yahoo, Netcraft. These methods are quiet and legal, perfect for the early stages of recon. Now let's talk about active subdomain enumeration. This involves trying out a list of common subdomains to see which ones exist. GoBuster bash GoBuster DNS d example.com -usr//wordlist/DNS subdomains -top 1,000,000 -11zen.txt. This tool takes a word list and checks which subdomains resolve. Amass, one of the most powerful tools. Run it like this, bash amass enum -d example.com. Amass uses both passive and active techniques and can find a lot more than simpler tools. Keep in mind, active scanning can generate traffic, so only use it on your own systems or with permission. All right, So you found 15, 20, maybe even 100 subdomains. Now what? You want to check which ones are live, use HTTPX or HTTP robe, see if any of them lead to login pages, API endpoints, or development tools. Check if any are using outdated or vulnerable technologies. Try accessing /robots.txt, admin, or /uploads for clues. And finally, scan them with tools like Nmap, Nikto, or dir search. Every subdomain could be an entry point. Treat each one like a new door to test. One important reminder, only do subdomain enumeration on sites you own, in your lab, or with written permission. Tools like GoBuster and Amass can trigger alerts, especially if scanning company-owned infrastructure. We're here to hack ethically, not get into legal trouble. Let's quickly review. Subdomains can expose forgotten or vulnerable systems. Passive tools, crt.ash, VirusTotal, Sublist3er, active tools, GoBuster, Amass. After finding subdomains, scan them, test for weaknesses, and build your attack strategy. Subdomain recon is the key to discovering what your target doesn't want you to see. And that's it for this video on subdomain enumeration. In the next part, we'll use these subdomains to do directory brute forcing to find hidden admin panels, upload portals, and sensitive files. If you're enjoying this journey, make sure to like, subscribe, and leave a comment if you've used any of these tools before. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. I'll see you in the next one. Welcome back to Secure 7, and this is Module 3, Part 5 of our course, Learn Website Hacking Penetration Testing from Scratch. So far in this module, we've explored how to gather DNS records, find subdomains, and fingerprint websites. But now, we're moving into one of the most common and effective recon techniques, directory enumeration, also known as directory brute forcing. Let's break it down, learn the tools, and see how hackers find those hidden admin panels and upload folders. So what exactly is directory enumeration? It's the process of trying to find hidden files and folders on a website, things that aren't linked on the homepage but still exist on the server. You might discover things like /admin, load backup, /config/, or even /dev-test.php. These paths can reveal login panels, sensitive data, or even files that shouldn't be public. Think about it. If a developer forgets to secure an internal folder or leaves an old backup online and you find that folder using directory brute forcing, boom, you've just found a real vulnerability. Many web applications hide critical functions behind non-public URLs. Directory enumeration helps you uncover forgotten admin dashboards, upload pages without authentication, files with source code, old or unmaintained tools that can be exploited. It's simple but powerful. Let's look at some tools you can use to perform directory enumeration. TAN, DIRB, command line brute force tool that uses word lists to find directories, pre-installed on Kali Linux. 2. GoBuster, fast and reliable, can be used for both directory and DNS brute forcing. 3. Dir search, Python-based tool, clean output and supports recursion. You'll also need word lists, lists of common folder and file names. You can find them in Kali Linux, bash usrshare/wordlists/dirb/, or use the famous seclists collection, bash git clone #github.com/danielmiessler/seclists.git. Let's run our first directory scan using dirb. Example, bh.example.com. By default, it uses a basic word list and tries to find common directories. Want to use a bigger list? Bash dirb/example.com/wordlist/common.txt. You'll start seeing results like +/example.com/admin.com/login/example.com/uploads. Now you've got entry points to test further. GoBuster is super fast and easy to use. Here's the basic command. Bash GoBuster dir -u/burp example.com wusr/wordlist/derbscommon.txt. You can add flags for status codes, file extensions, or threads. Bash GoBuster dir u/example.com wordlist.txt.php HTML-T50. This makes it much faster for larger websites. Pro tip, focus on 200 OK results. Those are valid pages you can open and explore. Once you've found hidden directories, here's what you do next. Visit them manually in a browser. Use tools like Burp Suite to intercept requests and test input. Try accessing /admin or /login with default credentials. Checks uploads for insecure file upload flaws. Download and inspect any .zip, .back, or .sql files. Directory enumeration gives you an inside view of the application and often a direct path to exploitation. Quick reminder: only perform directory brute forcing on websites you own or have permission to test. Tools like Burp and GoBuster can flood servers with requests and trigger alarms. Use them responsibly in labs, CTF platforms, or in real-world bug bounty programs with clear rules. Let's recap. Directory enumeration helps you find hidden files and folders. Tools, Burp, GoBuster, DirSearch. Use good word lists like sec lists. Focus on 200 responses, explore admin panels, upload folders, or backup files. Always stay ethical and follow scope rules. One hidden directory could be your gateway to full access. And that's it for this lesson on directory enumeration. In the next part, we'll explore search engine hacking, also known as Google dorking, where we find sensitive data using just Google. If you're learning something valuable in this course, make sure to like, subscribe, and leave a comment below. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. I'll see you in the next one. Hey Amro, hey everyone. Welcome to Module 4, Part 1 of our course, Learn Website Hacking Penetration Testing from Scratch, here on Secure 7. In this video, we'll focus on one of the most common and most dangerous vulnerabilities in web applications: file upload vulnerabilities. Yes, that simple file upload button can open the door to complete system compromise if not handled properly. Today, we'll look at how hackers discover these flaws, upload malicious files, and execute them to take control of a website. Let's get started. 1. What is a file upload vulnerability? So what exactly is a file upload vulnerability? It happens when a website allows users to upload files, but doesn't properly validate file extensions, check the MIME type, restrict where files are stored, or prevent execution of uploaded files. That means an attacker can upload a malicious script like a .php file and then execute that script on the server through their browser. Imagine uploading a file like this: php system get timdeed. Save it as shell.php, upload it to the site, then visit hp/target.com/shell.php.cmwomi. Boom, you're executing system commands. In real-world hacking, the first step is recon. Look for places where the website allows users to upload profile pictures, submit documents or resumes, post screenshots or images, attach files through forms. Check URLs like /upload.php/edit-profile/contact us. These forms are often overlooked by developers and they're perfect targets for this kind of attack. Let's try uploading a basic shell. Here's our payload: php system get tinkmdo. Save this file as shell.php. Now go to the upload form, select the file and submit. If the server doesn't restrict .php files, saves the file in a web accessible folder, doesn't rename or sanitize the file, then you'll be able to visit http://target.com/shell.php. And just like that, you have RCE, remote code execution. You can run womi ls-la uname-a and see actual server responses. This kind of vulnerability is dangerous because it gives total control to an attacker. With a web shell, an attacker can explore the file system, view or download sensitive files, run custom scripts, upload a reverse shell and get full terminal access. If the server has weak permissions, the attacker might even pivot into internal systems. Some websites may have protections in place, such as only allowing .jpng.pdf, renaming uploaded files, validating file content, blocking execution in upload folders. But if any one of those layers is missing, it could still be vulnerable. If the file is uploaded with your PHP code and stored in a public folder, and you can access it by URL, then you've won. That's a real critical vulnerability that needs to be reported immediately if you find it during a pen test or bug bounty engagement. Let's quickly recap what we've learned. File upload vulnerabilities allow attackers to upload and execute malicious scripts. A simple .php file can give remote access to the system. These flaws often hide in common upload features like profile pictures or contact forms. Testing should include multiple file types, content headers, and front-end versus back-end filters. If not properly secured, even a .jpeg file can become a weapon. And this is just the beginning. In the next parts, we'll explore advanced techniques, reverse shells, and intercepting requests to bypass filters. And that wraps up part 1 of our file upload vulnerability module. In the next video, we'll take this even further by learning how GET and POST requests work and how we can manipulate them to bypass security filters and sneak malicious payloads through. If this video helped you learn something new, be sure to like, subscribe, and drop a comment below. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in part 2. Hey everyone, welcome back to Secure 7, and you're watching Module 4, Part 2 of your course, Learn Website Hacking Penetration Testing from Scratch. In the last video, we successfully uploaded a basic shell using a file upload vulnerability. But how do file uploads, or any data for that matter, travel from your browser to the server? That's where GET and POST requests come in. And today, we'll not only understand them, but we'll also learn how to intercept and manipulate them using Burp Suite. This is the backbone of all web hacking. So let's get into it. When you click a button, submit a form, or upload a file, your browser sends an HTTP request to the server. There are many types of HTTP methods: GET, POST, PUT, DELETE. But for most of web hacking, we focus on the two main ones: GET, POST. Let's break them down. GET request. A GET request is used to retrieve data from the server. It's commonly used for things like search queries, loading profile info, navigating pages. Example, http:/example.com/search query equals admin. Here, the data query equals admin is sent in the URL. Characteristics of GET. Visible in browser history, can be bookmarked, easily intercepted, not secure for some sensitive data. As hackers, GET requests are gold. We can test for SQL injection, try different usernames, see URL patterns, and guess endpoints. A POST request is used to send data to the server, especially when dealing with login forms, file uploads, creating accounts, submitting sensitive information. Example, let's say you're logging in, HTML form method equals post, action /login, input name equal password value 13456 form. POST sends data in the body, not the URL. More secure than GET, but only if encrypted, i.e. HTTPS is used. As hackers, POST requests let us brute force logins, bypass filters, upload payloads, intercept and modify request bodies. Part 4. Intercepting requests with Burp Suite. Demo, let's fire up Burp Suite and set up interception. Step by step. 1. Open Burp Suite Community Edition. 2. Go to Proxy Intercept. 3. Make sure Intercept is on. 4. Configure your browser proxy, IP 127.0.1, port 8080, or use Burp's embedded browser. Now, when we submit a form on any website, Burp will catch the request. Whether it's GET or POST, we'll see request headers, parameters, cookies, full body content. Sometimes you'll bypass authentication or view restricted content. It's called insecure direct object reference. Now let's intercept a post request. Example login form, post/login HTTP 1x1 host, target.com, username, admin, and password 123456. What can we do here? Try different usernames, test weak passwords, try SQLi payloads like username equals admins and password is equal to anything. Or if it's a file upload request, change the file name, change the content type, try uploading a .php instead of .jpg. This is where real hacking begins, manipulating the requests the app depends on. When you understand GET and POST requests deeply, you can test for SQL injection, perform brute force attacks, bypass login logic, upload reverse shells, exploit hidden parameters, bypass file filters. You'll also use Burp Repeater and Intruder. We'll cover that soon to automate and repeat your payloads. Let's quickly recap. GET equals visible, used to retrieve info, great for recon. POST equals hidden in the body, used for sending data like passwords or files. Both can be intercepted and manipulated using Burp Suite. Hackers use these to inject payloads, bypass logic, and test input validation. Understanding requests is the core of web hacking. Without it, you're just guessing. Now that we've mastered this, we'll use this skill in future modules, especially when attacking login forms and exploiting file uploads. And that's it for Module 4, Part 2. You now understand GET and POST requests and how to use Burp Suite to intercept and manipulate them. In the next part, we'll explore advanced file upload exploitation, bypassing content type filters, using double extensions, and preparing for reverse shells. So make sure to like, subscribe, and leave a comment below if you're learning something new. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in the next one. Hey everyone, welcome back to Secure 7, and you're watching Module 4, Part 4 of our course, Learn Website Hacking Penetration Testing from Scratch. So far in this module, we've discovered insecure file uploads, intercepted and manipulated requests, uploaded a PHP shell. Now comes the real impact. In this video, we're going to execute a web shell, run server-side commands, and establish a reverse shell connection for full terminal access. Let's jump in, but always remember, use this only in legal lab environments. A web shell is a small script, often written in PHP, that gives an attacker remote control over a server via the browser. Imagine you're visiting a web page like h/target.com/upload/shell.whois. Behind the scenes, it's executing system commands on the server and sending the result back to your browser. This is remote code execution via HTTP. Part 2, building and uploading the shell. Let's build a simple PHP web shell. That's the user context under which the web server is running. Now try more commands. ls ccamd uname -a, and we go cat/eat/pacify. You're now inside the server using a simple PHP shell. The browser-based shell is useful but limited. If you want full terminal access to use tools like cd, pwd, nano, wget, or even launch Metasploit payloads, you'll need a reverse shell. A reverse shell is a connection from the victim back to the attacker, lets you interact in a real terminal, bash, feels like you're inside the target machine. Let's set it up. Part 4, Reverse Shell Demo, Netcat Edition. You're inside the system with a fully interactive shell. This is powerful, but also dangerous. Never use reverse shells on live systems unless it's your own environment, you have written permission, or it's a legal bug bounty platform. Defense tips: block PHP execution in /upload/folder, validate file type and content, use antivirus CDR to scan files, monitor outgoing traffic for suspicious connections, use a web application firewall. Let's recap everything we learned in this session. A web shell is a script that runs OS commands via the browser. We uploaded a PHP shell and tested it in a real browser. Then we created a reverse shell using Netcat and PHP. We gained full shell access to the server. And finally, we talked about how to defend against this. This is the core of file upload exploitation. And now you fully understand it. And that's it for Module 4. Part 4, Web Shell Execution and Reverse Shell Demo. In the next part, we'll go into the defensive side, how to properly fix and secure file upload vulnerabilities so your apps don't become victims of what we just did. As always, if this helped you learn something valuable, smash the like button, subscribe, and drop your questions below. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in Part 5. Hey everyone, welcome back to Secure 7, and this is Module 4, Part 5 of your course, Learn Website Hacking Penetration Testing from Scratch. In the previous lessons, we discovered and exploited file upload vulnerabilities, uploaded shells, and even created reverse shell access. But now it's time to change our mindset. In this video, we'll talk about how to fix and secure file uploads, because as ethical hackers, it's not enough to break stuff. We must also understand how to protect it. Let's start with the big question. Why are file upload features such a big risk? Because they allow direct user interaction with the server's file system. A single mistake, like trusting the file extension, can let an attacker upload web shells, .php, malware, scripts, or even full web shells for server takeover. Real-world breaches, including some big companies, have happened because of this exact vulnerability. So let's learn how to block it properly. All right, here are the key steps developers and sysadmins should take to secure file uploads. Let's go one by one. 1. Strict file extension whitelisting. Only allow trusted file types like .jpg, JPEG, PNG, PDF, docx. Never allow PHP, PHP5, PHTML, ASP, SH, and don't rely on a blacklist. Use a whitelist. 2. MIME type and content verification. Check the real content of the file, not just the name or header. Use backend code, like PHP's finfo file, to verify file type. Hackers can fake the MIME type as image JPEG, but still upload PHP inside. 3. Rename uploaded files. Never store the uploaded file with the original name. Instead, rename the file using a random string or hash, a UUID, or server-generated file name. This avoids malicious names like shell.php or backdoor.php.jpg. 4. Store files outside the web root. Move uploads to a directory that is not accessible via the browser. Example, /var upload /safe var www.html upload /risky. This way, even if a script is uploaded, it cannot be executed. 5. Block script execution with Taxs, Apache. If you must store files in a public folder, disable script execution with Apache, files match, PHP, PHP7, DORE. Order denied, allow deny from all files match. This stops the server from parsing uploaded scripts as executable code. #6. Set file and directory permissions properly. Never give writes execute permissions to the same folder. Example, avoid chmod 777. This allows anyone to upload and execute. Instead, use chmod 644 for files, cmod 755 for folders. 7. Scan uploaded files. Use antivirus tools like ClamAV, VirusTotal API, commercial file scanners, especially useful in enterprise apps where users upload docs, resumes, or images. 8. Limit upload size and type. Set limits. Max file size, e.g. 5 MB, allowed types only, e.g. PDF, JPG. Reject zip, tar, rar unless absolutely required. Prevents DOS or massive data uploads. 9. Use CAPTCHA or auth for upload forms. This protects against bots uploading malware in bulk, automated attacks, script kiddies. Also, log every upload attempt, including IP address, file name, user account if logged in. 10. Don't rely on client-side validation. Client-side filters like JavaScript extension checks are easily bypassed. An attacker can modify the request using Burp, disable JS in their browser, use command line tools to upload directly. Always validate on the server. Let me show you a few common mistakes that lead to compromise. Accepting .jp but trusting the header and storing as is, allowing .php.jj but not checking the file content. Letting files be uploaded into a folder like //upload/ with public access, not logging uploads, no way to detect abuse, not checking file names for traversal patterns like /etc/passwd. Just one of these mistakes can be enough for a full compromise. Whitelist extensions prevents dangerous file types, MIME type validation, blocks disguised scripts, rename files, removes predictable malicious names, store outside web root, stops direct access to uploaded scripts, disable execution via .ataccess, stops server-side parsing, sets secure permissions, avoids accidental execution, file scanning, detects embedded malware, limit file size and type, prevents abuse, log upload activity, detects malicious behavior, CAPTCHA and auth controls, prevents bots or unauthenticated uploads. Let's wrap this up. File uploads are useful, but dangerous. Most file upload vulnerabilities happen due to developer mistakes. As ethical hackers, you must test these properly, and as defenders, you must build multiple layers of protection. If you're building or auditing web apps, always ask, can a malicious user upload something dangerous and make the server run it? If the answer is yes, you need to fix it. And that's a wrap on Module 4, Part 5, Fixing File Upload Vulnerabilities. You now know how to prevent dangerous uploads, harden the server, and spot common developer mistakes. In the next module, we're moving into another critical attack surface, where hackers trick the login system into letting them in without the correct credentials. If you're learning something valuable, don't forget to like, subscribe, and comment down below with your questions or feedback. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. Hey everyone, welcome back to Secure 7, and you're watching Module 5, Part 1 of our course, Learn Website Hacking Penetration Testing from Scratch. In this part, we're going to explore a very powerful and dangerous type of vulnerability called code execution vulnerability, also known as command injection. We'll test this inside a safe lab using DVWA, Damn Vulnerable Web Application. By the end of this lesson, you'll understand what command injection is, how to detect it, and how to exploit it step by step in a real-world vulnerable app. Let's begin. Let's break it down. A code execution vulnerability happens when a website takes user input and sends it directly to the operating system without checking or filtering it. This lets the attacker inject system-level commands like whomi ls ping cat /etc passwd. Imagine the website says, hey server, ping this IP, but you say ping this IP and also tell me who you are. That's the logic flaw we'll exploit. Let's start our lab. 1, make sure you have DVWA running on your vulnerable machine like XAMPP or Metasploitable. 2, in your browser, go to /targetip/DVWA/3. Log in using username, admin, password. 4, go to the DVWA security tab on the left. 5, set security level to low and click submit. Now on the left sidebar, click on command injection. This is our playground. You'll see a form that says, enter an IP address to ping. This is where the server takes the input and runs a command like php system ping $get IP. Let's start with a safe input, 127.0.0.1. Click submit. You'll see ping results below. Good, it's working. Now, let's test for command injection. Try this, 127.0.0.1, whomi, hit submit. Boom. Now look at the output. You'll see www-data. That's the user the web server is running as. That means our second command got executed. We just exploited a code execution vulnerability. Let's try some more payloads to confirm and explore further. Header example 1, 127.0.0.1 ls lists all files in the current directory. Example 2, 127.0.0.1 and then uname-a shows system information. Example 3, 27.0.11 woomi runs the second command only if the first fails. You can also try 127.0.1 cat etc/passwd. This will try to display user account info. You now have real command line control over the server through a web browser. Part 5, why it works. Let's break down why this works behind the scenes. The server is probably running a PHP function like php system ping get IP. So when we type 127.0.1 woomi, the actual command becomes ping 127.0.1 woomi, and the shell happily runs both commands. The website doesn't sanitize or escape our input, and that's the core problem. This vulnerability is known as command injection, OS command injection, and if it's remote, even RCE, remote code execution. If you're wondering how serious this is, command injection is one of the most dangerous vulnerabilities out there. An attacker could create backdoors, read or modify sensitive files, download malware, create new user accounts, or pivot deeper into the internal network. And all of this just because of a poorly handled input. Let's do one more thing, intercept and manipulate the request using Burp Suite. 1. Open Burp Suite. 2. Turn intercept on. 3. In DVWA submit 1 to 4. Burp will capture the request. HTTP get vulnerabilities exec/IP equals 127.0.1 and submit. 5. Now modify the IP value in Burp. IP equals 127.0.1 woomi. 6. Forward the request. Result, we get command output back in the browser from a request that we edited mid-flight. That's the power of Burp Suite plus command injection. Let's recap what we've learned in part 1. Code execution happens when input is passed directly to system commands. We tested DVWA's vulnerable form with simple injections, confirmed successful exploitation with commands like WHOIS, explored different operators, and Virginia, intercepted and manipulated the HTTP request using Burp Suite. This is the foundation of understanding command injection, and you're now ready to move to more advanced payloads. And that's it for Module 5, Part 1. In the next part, we'll go one step further, using this same vulnerability to gain a reverse shell, giving us full terminal access to the target machine. Make sure to like, subscribe, and leave a comment if you're learning something new. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in Part 2. Hey everyone, welcome back to Secure 7, and this is Module 5, Part 2 of your course, Learn Website Hacking Penetration Testing from Scratch. In the last part, we learned how to exploit code execution vulnerabilities using a simple form in DVWA. Today, we're going to take that attack one step further. We'll use command injection to gain a reverse shell, giving us full terminal access to the target server. Let's jump into the lab and make it happen. First, what is a reverse shell? A reverse shell is when the target machine connects back to the attacker machine and gives the attacker an interactive command line shell. This is different from a web shell. With a reverse shell, you're inside the system directly, like opening a secret terminal, and we're going to create one using nothing but a vulnerable form and a bit of bash. Lab prep. Before we start, make sure DVWA is running and set to low security. Kali Linux is on the same network. You know your Kali IP address, bash IPA. Note down your IP, like 192.168.1100. We'll need that for the reverse shell. On your Kali terminal, open a Netcat listener, bash nc-lvnp4444. This will listen for an incoming connection on port 4444. Keep this terminal open. Don't close it. It's our trap. Now we need to inject a reverse shell payload into DVWA's form. Paste this into the DVWA command injection field. Click Submit. If everything works, you'll see no output on the page. But look at your Kali terminal. You'll see something like on port 44444. You now have a shell on the target machine. Try some basic commands, bash WHOIS id uname-a ls ella. You're executing real commands on the remote server in an interactive shell. That's full system access. You can also use Burp Suite to intercept and inject the payload manually for more control. Let's switch roles. How do we stop this? Defensive tips. Sanitize all user input. Never pass input into system commands. Use parameterized functions or built-in APIs instead. Disable dangerous binaries like ND, bash, Perl. Use a web application firewall, WAF. Monitor for outbound connections. Apply least privilege. Don't run the app as root. The only reason this worked is because DVWA was vulnerable, but many real apps make the same mistakes. Let's recap everything we just did. Set up a Netcat listener on Kali, crafted a bash reverse shell payload, injected it through a web form using command injection, caught the connection and got full terminal access, and explored alternate payloads plus prevention tips. This is how attackers go from input field to system control, and now you know how. And that's it for Module 5, Part 2, Reverse Shell via Code Execution. You've now taken your first major step into remote system exploitation, using nothing but a web form and a bit of bash. In the next part, we'll look at how to fix these vulnerabilities from the developer and DevSecOps side so you can secure your apps properly. If you're enjoying the course, don't forget to like, subscribe, and drop your questions in the comments. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in Part 3. Hey everyone, welcome back to Secure 7, and this is Module 5, Part 3 of your course, Learn Website Hacking Penetration Testing from Scratch. In the last 2 lessons, we learned how attackers exploit code execution vulnerabilities and even gained reverse shell access using nothing but a vulnerable web form. But now let's put on our defensive hat. In this session, we'll learn how to prevent command injection, how to secure user inputs, and what good coding practices stop remote code execution. Let's begin securing our apps. Let's quickly revisit the root cause of code execution flaws. In DVWA, the vulnerable PHP code looked something like this. PHP cmbed equals ping or get IP system all. So if the user inputs 127.1 WHOIS, it gets passed directly to the shell as ping 127.0.1 WHOIS, and the attacker controls the command line. This happens because the app blindly trusts input and sends it straight to the operating system. That's the mistake we must fix. Let's break down the principles every developer should follow when working with system-level commands or user input. 1. Avoid using system or exec. Don't call the OS unless absolutely necessary. Use built-in programming logic instead. Bad. PHP system ping $get IP. Better, use built-in PHP or backend code to validate input, or even better, avoid OS calls altogether. 2. Use parameterized inputs. If you must pass input into a command, sanitize it first. Use escape shell arg in PHP. PHP IP equals escape shell arg IP. System ping $IP. This escapes characters like an N, so they can't be used to inject other commands. 3. Whitelist valid input only. If you're expecting an IP address, only allow digits and dots. Use regex to validate. PHP if pregmatch /09 plus $get IP system ping escape shell arg IP else echo invalid input. Better yet, use a library function to validate IP format. 4. Avoid direct shell calls in web apps. 99% of the time, you don't need to run system commands from a web app. Instead, use API calls, use database logic, process data securely in code, and hey, if shell access is required, isolate it from user input. Let's rewrite the vulnerable DVWA code in a secure way. Original vulnerable code PHP cmd ping get IP system deem. Secured version php.ip equals if filter var filter validate IP $safe IP escape shell arg system ping data c4 safe gorep else echo invalid IP address. We're now validating the input as a proper IP address, escaping shell arguments, limiting the number of ping attempts, avoiding unnecessary shell commands. This code is much harder to exploit. In addition to secure coding, let's talk about server-level protection. 1. Use least privilege. Never run your web server as root. Use a restricted user like www-data. 2. Disable dangerous binaries on production systems. Disable tools like Netcat, bash shells, Perl PHP interpreters if not needed. 3. Monitor outbound connections. Set up alerts for outgoing TCP connections to unknown IPs. Reverse shells rely on outbound connections. Apply web application firewalls, WAFs. Use mod security or Cloudflare to detect shell-like patterns, block suspicious commands. 5. Use container isolation. If possible, isolate your web apps using Docker, Crute, CLinux, AppArmor. That way, even if compromised, the attacker is trapped inside a limited environment. Security measure. Why it helps. Avoid system calls, removes risk entirely. Use escape shell arg, prevents input from breaking the shell. Validate user input, blocks unexpected commands or characters. Whitelist IP or domain format. Only allow known safe patterns. Disable dangerous binaries, removes tools attackers rely on. Use low privilege users, limits attacker capability even if exploited, monitor network connections, detects reverse shell attempts, apply a web application firewall, stops payloads before they reach the backend. And that's a wrap on Module 5, Part 3, Fixing Code Execution Vulnerabilities. Let's remember, exploiting is just one side of hacking. Real ethical hackers fix the flaws too. And the best security comes from thinking like an attacker and a developer. In the next module, we'll explore another major vulnerability and how attackers break into systems without a password. If this module helped you, don't forget to like, subscribe, and share this with your dev or security friends. This is Parth from Secure 7, and you're watching Learn Website Hacking Penetration Testing from Scratch. See you in Module 6. Welcome back to 7, the place where we learn ethical hacking and cybersecurity the right way. Today, I've got something super practical for you. We're talking about a training that teaches you how to hack websites like a real attacker, and more importantly, how to secure them like a pro. So, if you've ever wondered what web hackers really do behind the scenes, stick around. All right, so here's the deal. This course is all about understanding how websites and web apps get hacked and how to stop those hacks. Now, before you panics, yes, this is 100% legal. It's ethical hacking. You'll be practicing in safe environments using real vulnerabilities in test labs. So it's not just some theory from a textbook, it's real-world stuff. Let me break it down. Here's what you'll actually learn in this training. First, how the web works, like HTTP, cookies, sessions, basic stuff, but super important. Then you get into recon, finding targets using tools like Google dorking, subdomain tools, and scanning ports. After that, you dive deep into vulnerabilities, the juicy stuff. We're talking SQL injection, cross-site scripting, XSS, file upload bypass, command injection, login bypasses, and access control flaws. You'll not only exploit them, but also learn how to fix them. Now, this is the best part. You're not just watching videos. You'll actually do the hacking yourself. With real working labs, you'll try these attacks on purpose-built vulnerable websites. And once you break in, you'll learn how to patch the issues, secure the code, and defend against future attacks. So you'll see both sides, the attack and the defense, which is exactly how a real ethical hacker thinks. And don't worry, you won't be left in the dark with tools. You'll get comfortable using tools like Burp Suite, OWASP Zap, sqlmap, Nikto, Hydra, Derb, Postman. Yep, even that. Even if you've never used these before, the training walks you through step by step. Now, you might be wondering, is this course for me? If you're just starting in ethical hacking, a student prepping for CEH or OSCP, a developer wanting to secure your code, or even someone just curious about cybersecurity, then yeah, this is for you. You don't need to be a pro. You just need to be curious. Let's be real, cybersecurity is hot right now. Knowing how to hack and defend web apps is one of the most in-demand skills today. This training is a great foundation if you want to go into bug bounty hunting, web app pen testing, security engineering, even freelance consulting. And guess what? It even helps you prep for certs like WHOIS, CEH, and EWPT. Here's what's included in the training package: lifetime access to lessons, step-by-step labs, downloadable resources, and a certificate at the end. It's like a full boot camp, but focused just on web hacking. All right, if you're serious about learning how real hacking works and you want to level up your skills, check the link in the description. That's where you can get access to this course. And of course, if you found this video helpful, hit that like button, subscribe to Secure 7, and leave a comment if you have any questions. Thanks for watching. Stay ethical, stay curious. I'll see you in the next one. Welcome back to... Hey everyone, welcome back to Secure 7, your go-to channel for learning ethical hacking from scratch. Today, we're kicking off Module 1 of our course, and we're starting with something every hacker needs to master: a basic overview of Kali Linux. If you've ever wondered, what is Kali Linux? Why do hackers use it? You're in the right place. Part 1. What is Kali Linux? So let's start with the basics. Kali Linux is a specialized Linux distribution created specifically for penetration testing and ethical hacking. It's built and maintained by Offensive Security, and it comes preloaded with hundreds of tools used by hackers, security professionals, and forensic analysts. Think of it like a hacker's Swiss Army knife. It's got everything from network scanners to password crackers. And the best part? It's free, open source, and based on Debian. Why use Kali Linux? Now you might ask, why Kali? Why not Ubuntu or Windows? Well, here's the thing. With Kali, you don't have to install tools one by one. Everything is optimized for hacking and security. It runs on low-spec machines. It's constantly updated for security pros. So instead of building your own hacking machine from scratch, Kali gives you a fully loaded lab ready to go. All right, let's take a quick tour of the Kali desktop. So when you first boot Kali, you'll see a clean interface, usually running XFCE or GNOME, depending on what you chose during install. Let's look at what's on the left. You've got shortcuts for Terminal, File Manager, and Browser. On the top bar, you'll find Settings, Power, Wi-Fi, and more. And of course, your Applications menu is where the magic happens. Open it up, and you'll see categories like Information Gathering, Vulnerability Analysis, Web application attacks, password attacks, wireless attacks. Each of these folders contains powerful tools you'll learn to use throughout this course. Let me show you some of the tools that come pre-installed. Nmap for scanning networks, Burp Suite for testing web apps, Wireshark for capturing packets, Metasploit for launching exploits, John the Ripper for cracking passwords, Hydra for brute force attacks. And that's just scratching the surface. Everything is organized by purpose. So even if you're a beginner, it's easy to find what you need. Now, Kali is still Linux under the hood, so you'll be working a lot in the terminal. You'll see a home folder, root access, and a very typical Linux-style file system.